Welcome to Section 4, Application Logging with Amazon CloudWatch, Google Stackdriver and Azure Log Analytics. In this section, we will explore and configure Amazon CloudWatch to store and visualize application logs in AWS. We will then explore and configure Google Stackdriver to store and visualize application logs in Google Cloud. And at the end, we will also learn a little bit about Microsoft Azure Log Analytics. Installing AWS CloudWatch Logs agent to store application logs in AWS. If you search on the internet, there is a lot of information and documentation about Amazon CloudWatch. There are various installation instructions depending on how one needs to install the agent. The installation method and procedure varies depending on whether or not you are installing the agent on an EC2 instance or on an on-premises compute instance. For this course, the process of installing and configuring the Amazon CloudWatch agent is very similar to the one set out by the AWS for on-premises compute instances. In order to speed up the process of installation and configuration of the Amazon CloudWatch agent, I have prepared the necessary files required by the agent to work, and I will go through them one by one as we progress through this video. Let's start from our application Docker file. In order to get the Amazon CloudWatch agent up and running, we first need to get it from somewhere. So let's add the commands necessary to install and configure the Amazon CloudWatch agent manually. What I just did was to add the command that downloads the agent binary for the specific version of operating system we are using. That is followed by the command needed to actually install the package downloaded by the previous command. What we are doing right after that is to then copy the .aws folder to the root folder. Then we are copying two configuration files to the appropriate folders. You will notice how we haven't created the AWS folder as well as the configuration files. So let's start from the AWS folder. The .aws folder is typically required by AWS tools for authentication and configuration. In this folder, we are going to add two files, the config file and the credentials file. Let's do that. The config file contains the configuration for the AWS region. What we are saying here is that by default, we want to use the EU West 1 region, which is the Ireland region in AWS. The string within the square brackets is the name of the configuration profile. In this case, the profile is going to be named Amazon CloudWatch Agent. Now let's create the credentials file instead. With the same configuration profile specified, you can see the credentials file contains the access key and the secret access key. These credentials are required by the agent in order to send metrics and logs to AWS. Notice how we haven't actually specified any credentials, but we have only set two placeholders. As this file contains secrets, we will define them in the concourse parameters YAML file as we did before for the other secrets. Before we can do that though, we first need to generate them in our AWS account. So let's go and do that. From the AWS console homepage, you should see a search bar. Type IAM in there. You should see a link after that. Click on it and go through the IAM section. Assuming you already followed the initial root account setup steps recommended by AWS, click on Users and then on the username of the user you previously set up. Now click on the Security Credentials tab, and under the Access Keys section, click on Create Access Keys and create a new pair of access keys. When the pop-up appears on screen, copy the access key ID and the secret access key and paste it in the concourse parameters YAML file. With the AWS credentials in place, we can now take care of the Amazon CloudWatch agent profile configuration. Let's head back to the Docker file. The AWS access key and secret key will be injected within the application container via environment variables and then replaced at runtime before starting the application. So let's define the environment variables first. Now what we need to do is to refactor the container command we have because we will also have to take care of the runtime configuration. Let's create a script that will just do that. As you can see from the script, before starting the Amazon CloudWatch agent, we are injecting the environment variables containing the secrets in the credentials file. Then, we are starting the application as usual. With the startup scripts ready, we only need to reference it in the Docker file. What we need to do is to change the command statement in the Docker file. The only thing left now is to change our base image. The Python 3.4 base image we are running is using Debian 9 as its operating system. But at the time of recording, AWS states on their documentation that Debian 8 is supported for the Amazon CloudWatch agent, so we need to change the reference in the from statement at the top of our Docker file. First, I will add the JSON file which declares the data we want to send to AWS. In our case, it will be a collection of logs from the agent as well as container metrics such as CPU, memory usage, disk, etc. After adding the JSON file, we now need to add the TOML file where the agent configuration parameters are defined. Now the only thing left is to change the Kubernetes resource file and the pipeline YAML file. I will start by changing the pipeline YAML file first. After adding the reference to the new secrets, let's update the deployment command. What we are doing differently here is to simply create a Kubernetes secret resource which will contain the AWS secrets. With those in place, let's finally add the reference into the Kubernetes deployment resource. The deployment now references the two environment variables taken from the Kubernetes secret resource. Those two environment variables will then be read by the startup script and replaced within the AWS credential file so that the Amazon CloudWatch agent will be able to write the logs and metrics to AWS. I think we are ready for deployment now. Let's build a Docker container and push it to the registry first. We are now building the Docker container image, as usual. Let's wait until it finishes. With the Docker image built, let's now push it to the Docker registry. As you can see, we are now pushing the new image. Let's wait until it finishes. Okay, with the newly built image pushed, let's update the continuous deployment pipeline. And finally, let's commit the new code changes and push them so that the pipeline can deploy everything to production. With the changes pushed, let's take a look at the pipeline. We should see it starting a new deployment soon. As you can see, the continuous deployment pipeline is doing its job. Now that will deploy the new changes, so from now on we should expect the Amazon CloudWatch logs to go into AWS.